Hello everyone, my name is Matt Kugler, and today I will be walking you through the AP Calculus AB 1995 free response question number 5. We're starting off here looking at the problem. It reads, as shown in the figure above, water is draining from a conical tank with height 12 feet and diameter 8 feet into a cylindrical tank that has a base with area 400 pi square feet. The depth h in feet of the water in the conical tank is changing at a rate of h minus 12 feet per minute. The volume V of a cone with radius r and height h is V equals 1/3 pi r squared h. Now moving into part A of the problem, it's asking us to write an expression for the volume of water in the conical tank as a function of h. So first we're going to write down what we know, which is the volume of a cone equation, which reads V equals 1/3 pi r squared h. Next we're able to relate the radius and the height of the cone in order to write that expression in terms of h. So we're able to solve for r in terms of h, and then ultimately plug this back into the volume equation. So simplifying r over h equals 4 over 12, we're able to know that r equals 1/3 h, which then can be plugged back into our volume equation. And now we have an unsimplified expression for the water in the tank as a function of h. Now we can take our unsimplified expression, which reads V equals 1/3 pi times h over 3 squared times h, and simplify that expression to get us our final answer as V equals pi over 27 h to the third. So now this is our expression for the volume of water in the conical tank as a function of h. Next we're going to move into part B, which reads, at what rate is the volume of water in the conical tank changing when h equals 3? Indicate units of measure. So we're going to start off with our expression from the previous part of the problem, which reads V equals pi over 27 h to the third. And then we're going to take the derivative of this expression, and now it will be dv over dt equals pi over 27 3h squared times dh over dt. So now we're going to plug in our desired height and make the equation that we've created in terms of rate. So now we're able to plug in our h equals 3 and have dv over dt equals pi over 27 times 3 to the third times dh over dt. Next, we're able to take this equation that we've created here of 3 minus 12, which we know from the problem to be the depth h in feet of the water in the conical tank is changing at this rate. And then we can have our height, which is equal to 3, plugged into that. So we know 3 minus 12 is equal to the depth of the water changing. So now we're able to take this expression and plug it into the equation for dH over dt. Next, we could simplify this whole equation to find the rate of volume change, which is negative 9 pi cubic feet per minute. So this is our rate of volume change with the water in the conical tank when h is equal to 3. We have our change in volume with respect to time. And remember that this answer will be negative because the water is physically draining from the conical tank. Therefore, we're going to have a negative rate of change in the volume. Now, in the final part of the problem here, it asks us to let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing when h equals 3? Indicate units of measure. So now we have our expression for finding the volume of a cylindrical tank, which we know to be V equals pi r squared h. Now for this part of the problem, we're going to refer to V as u and h as y, due to better differentiate between the cylindrical tank and the conical tank. Next, we're going to take this equation and plug in our known area of the base, which finding the area of a circle is pi r squared. So now we know that we can plug in our 400 pi square feet where pi r squared is, and have our new expression read u equals 400 pi times y. And again, this is given to us. Now we can write an equation that uses volume and height with respect to time. So taking the derivative of our previous equation, we know that du over dt is equal to 400 pi dy over dt. So now we can take our du over dt, which is our change in volume with respect to time, and plug in the previous part of the problem, which solved for just that. So now we know that it's a positive number because the water from the conical tank is draining into our cylindrical tank. Therefore, our change in volume for the cylindrical tank is increasing. So now we have 9 pi over 400 pi, 9 pi equals 400 pi dy over dt. So now we can divide to find our change in y and simplify the whole expression. So now we have 9 pi over 400 pi equals dy over dt. Canceling the pi's out gives us our final equation to find the change in y with respect to time, which is 9 over 400 cubic feet per minute. And I believe that's all that we have for this question and everything. Oh, what's this? I don't know what's going on here. I am the one, the way your son don't need a gun to get respect up on the street. Under the sun.